Hello, thank you for joining the ERJ Podcast. My name is Dr. Don Sin. I'm the Deputy Chief Editor of the ERJ. Today, I'm joined by Dr. Bruno Crestani to discuss the current issue, which is focused on translational research studies in interstitial lung disease. Dr. Crestani is Professor of Pneumology at the Université Paris-Cité and the head of the Department of Pneumology at the Bichat Claude Bernard Hospital. Many thanks for joining us today, Bruno.
Hello, Don. I'm very happy to be here.
You and your colleagues have written a very inspiring editorial entitled Building Translational Bridges in Idiopathic Pulmonary Fibrosis Research, from Epithelial Dysfunction to Dysregulated Macrophage Polarization and Fibrogenesis, as an overview of the IPF-ILD translational studies published in the June issue of the ERJ. Would you be able to summarize the key advances in IPF research this year and to summarize your editorial?
Yeah, I think there were many papers published this year in the ERJ about the topic of ILD. In fact, the field of ILD is moving very quickly. And basic research, translational research, and clinical research are moving all together to bring new information to the field. And this is why we call this translational bridge, because we try to go from basic information that has been published to clinical application. For instance, I would take some key points, beginning perhaps with science around cyclic AMP. Cyclic AMP has been known since 30 years, that it played a key role in maintaining the homeostasis of fibroblast, type 2 cells, and alveolar macrophages. And cyclic AMP is being produced in the cell as a secondary mediator, intracellular mediator, under the influence of many receptors. And there is a balance of production of cyclic AMP and degradation of cyclic AMP. There is one paper dealing with this in this special June issue of the ERJ, looking at some molecules at the membranes that could in some way contribute to the regulation of intracellular cyclic AMP in alveolar macrophages. So this is very important, and it is really timely, because if you consider the recent innovations in the field, you probably read one of the May issue of the New England Journal of Medicine, where two papers were being published looking at nerandomilast as a treatment for idiopathic pulmonary fibrosis and progressive pulmonary fibrosis. And what is nerandomilast? Nerandomilast is an inhibitor of a phosphodiesterase E4B. And what is doing with this phosphodiesterase? It is degrading cyclic AMP. So by inhibiting the degradation of cyclic AMP, we keep cyclic AMP intracellularly and we inhibit the fibrotic process. And this is a really interesting, because it is a direct application in the clinical field of basic research. And one piece of this basic research is being published in this ERJ.
The cyclic AMP story is a perfect example of how understanding the mechanism of disease through translational research is leading to new therapeutic breakthroughs in IPF and probably other ILD-related conditions. So I think thank you for doing that. One of the, I think, interesting thing about translational research is the use of new technologies. And one example would be single-cell RNA sequencing. Can you give us an example of how new technology is making breakthroughs possible in our understanding of IPF or ILDs in general?
Oh, yes. And this is, again, something which is moving so quickly. If you consider the first study looking at the single-cell analysis of the transcriptome of the cells in the lung, in the fibrotic lung, was published only 6 years ago. It was in 2019. Since that paper, a seminal paper with Reifman as first author, there has been an efflorescence of papers dealing with that. And these papers were quite interesting because they showed us something that we never saw before. And what they showed us was the heterogeneity of the fibrotic tissue First, they showed us that in a fibrotic lung, there were changing in almost every kind of cell. And I will take just two examples. First, alveolar macrophages. We knew from the past that there were changing phenotypes of alveolar macrophage in the fibrotic tissue, but now with a single cell analysis, we are able to pinpoint some pro-fibrotic macrophage population, which, for example, will express some specific markers such as SPP1 at the transcriptomic level. And in this issue of the ERJ, you will see some specific work dealing with that. But with the same techniques, we have been, and many groups now in the world are looking at the fibroblast subpopulation, showing that there are appearance of pro-fibrotic fibroblasts, but the endothelial cell population are really being very much changed at the transcriptomic level. But what is more important is that if you do this kind of experiment from the whole lung, then you need to go back to the tissue and you need to have some spatial analysis, and this is called spatial transcriptomics at the single cell level. And if you go in that, again, this issue of a ERJ, you will see very nice pictures using spatial single cell transcriptomic, looking at where are these specific cells located in the fibrotic tissue.
Very good and very exciting. You have a second editorial in the June issue of the ERJ entitled Rejuvenation as a Future for Pulmonary Fibrosis, where you suggest that IPF and perhaps other related ILD conditions are really conditions of accelerated aging. Why do you say this, and what do you mean by accelerated aging?
Yeah, we wrote this editorial with Panayota Tsiri, and Panayota Tsiri is a long-term research fellow from the European Respiratory Society, and she's working in our lab currently, and she helped me writing this editorial. If all the data that we have considering idiopathic pulmonary fibrosis, and as you told, probably most of the fibrotic tissue are associated with some characteristics of the cells which are associated with aging. I will take a few of them. First, telomere shortening. It is clear that in idiopathic pulmonary fibrosis, if we look in the tissue, in the lung, almost in every patient, we will see shortened telomeres, particularly in type 2 cells. And we believe that this is a driver of the disease. And shortened telomere means aging of a cell. This is one point, and this translates to the genetics, to what we know of genetics of idiopathic pulmonary fibrosis. Probably the second thing we can look at is epigenetics. There have been a few papers suggesting that there is indeed epigenetic alteration in the cells from the lung, but also from the blood, which are associated with aging. And these epigenetic alterations are more frequent in patients with IPF as compared to age match control, very important to match for the age. And there are many other alterations. And I can choose one third, which is mitochondrial dysfunction. There is a bunch of papers indicating that the mitochondria, particularly in type 2 cells, are dysfunctional in the fibrotic tissue, either from idiopathic pulmonary fibrosis or from progressive pulmonary fibrosis. And this mitochondrial dysfunction is very similar to mitochondrial dysfunction, which is seen in aging people. This is why, putting all these things together, and this is what we write in this editorial, this is why we can say that IPF and other progressive pulmonary disease probably are a kind of accelerated aging.
So in other words, what you're saying is, we can measure aging not just by looking at a birth certificate of a patient, but at a cellular and maybe even an epicellular level by using these technologies at the telomere level or methylation, as in the case of epigenetics. So this is very exciting. And these data will tell us something about biological aging, and this will help our patients understand their prognosis and perhaps lead to therapeutic breakthroughs. So speaking of which, is there any way we can reverse aging in IPF or or any other conditions? Can you speculate on some ways we can reverse aging?
Obviously, this is a very active area of research, not only in the fibrotic field or in the ILD field, but for instance, in COPD. What we can say that in experimental models, we can modulate the biological age or processes associated with aging. And for instance, one typical molecule is metformin. There are data suggesting that with metformin, we can modulate some biological processes which are associated with aging. And many of our patients are currently receiving metformin for treating their diabetes, but maybe this drug could be able to modulate aging, maybe in pulmonary fibrosis. And the second one is, what happens when with aging? With aging, some cells become senescent. Typically, the type 2 cell becomes senescent in the fibrotic tissue. And this senescent cell will produce some mediators. And among these mediators, some are chemokines, cytokines, and other mediators. And these mediators, we believe, are promoting fibrosis. So one target would be to take over these senescent cells with senolytics. And there are many groups currently looking for senolytic drugs that could be able to target the senescent cell, maybe killing them or depleting them or just inhibiting them to dampen the senescent activity and stop this senescent process. This is a very active field in the world, obviously, because rejuvenation for any human being could be of interest. Just to finish with that, there could be something specific in IPF as compared for COPD, for instance. And in this very nice paper published in the ERJ with Gobi as first author, they looked at biological aging in patients with IPF, and they compared with COPD patients. And the biological age was almost 10 years older as compared to chronological age in patients with IPF. And this was worse than in patients with COPD. So it depends also on the disease.
Do you think aerobic exercise or taking in antioxidants, and last year we had a podcast on beetroot juice as a source of antioxidant. Do you think that would be good for IPF patients in terms of slowing down aging or even reversing aging?
Oh, this is very important. This is something we tell our patients. You should keep on exercising because this will not change your disease, but it will improve your global health. And at the end, it will improve your well-being. So exercising, yes, breathing clean air. This is very important. There is a link between pollution, atmospheric air pollution, and biological aging in the lung. So this is also important. Maybe also taking antioxidants. This is ongoing research. I would not promote that, but probably having healthy food. This is probably also very important to keep biological aging as low as possible for IPF patients, for COPD, and probably for anyone.
Any last words on your editorials or about translational research in IPF in general that you would like to convey to our audience?
Yeah, my message is first, thank you to the ERS, because ERS is putting a lot of effort in promoting translational research in young investigators, helping young investigators from Europe to collaborate. And this is important because if we want to keep the research ongoing in the respiratory field, we need to help our young colleagues to go and to be supported. And this will be, I think, a key for the future.
Well, I think the future is very bright for not only our trainees, but our patients suffering from IPF and ILD because of all these translational studies and the therapeutic breakthroughs that have come and will continue to come over the next few years. So thank you so much, Bruno, for joining us today.
Thank you very much.
Dr. Crestani's 2 excellent editorials, as well as the key translational ILD IPF research papers discussed in the editorials, are now available on the ERJ website.